Our next topic is effect of an electric current on substances. Now we are aware that substances can be classified into conductors and non-conductors, where in this case we are actually interested in electrical conductivity and not thermal conductivity. So we know that metals conduct an electric current, but there is one non-metal that also conducts, and that is graphite. So we can therefore say in general that metals and graphite conduct electric current, whereas non-metals, apart from graphite of course, are non-conductors. We know of some non-conductors that can be used to protect electrical appliances, and we call them insulators. So actually all insulators are non-conductors. But not all non-conductors of course can be used as insulators, because there are some other consideration. We ask ourselves one small question, and that why do metals conduct? And that takes us back to structure and body, what you call the metallic board. What does a metallic board consist of?
So in the metallic board, the electron in the outermost energy level undergoes a process we call delocalization. So that is, the electron can now be attracted by any of the nucleus. Now, when that happens, then the electrons will be actually like moving around from one to the other, momentarily move to the next, and all around the structure. So we call them a sea of electrons. And they are moving at random.
But what will happen when you introduce an electric current?
The electrons, being negatively charged, will be directed now. They will get some direction because they will want now to move towards the positive terminal of the battery. So the electrons are moving out from the cells into this confusion now, but now that negative tends to pull the electron. So the electron now becomes directed, they move around. And that is how metals conduct an electric current.
We start with, say, two sodium atoms with their configuration 2, 8, and 1 electron in the outermost energy level. 2 electron, 8 electron, 1 electron in the outermost energy level. Now these two sodium atoms are not held to each other by any force of attraction. They can move very well. Then this electron, the electron in the outermost energy level, undergoes delocalization. So we say it is delocalized. So from the word local, belonging to, just in that locality, localized, pulled strongly towards one, delocalized. So this electron gets maybe somewhere there, this one goes somewhere there. So this electron can be, we have a resultant nucleus, okay, a resultant positively charged species there, because it has lost an electron. So the attraction between this and that now holds the two ions in quote together. So, and there'll be very many electrons. So we talk of a sea of electrons. The attraction to the to these ions to that electron will now constitute the bond between them. That's what we call a metallic bond. Now, if so, this electron, as it were, will be free to move anywhere. It can move and be attracted. This one can move, and they will be like there will be random movement. But when we introduce an electric current now, so and we have a bulb here, we have not really a bulb, we have a positive and a negative, a cell there. The electrons being negatively charged will be directed now. They will get some direction because they will want now to move towards the positive terminal of the battery. So the electrons are moving out from the cells into this confusion now. But now that negative tends to pull the electron. So the electron now becomes directed. They move around. And that is how metals conduct an electric current. Because the electrons are now moving in a specific direction. We note that the conductivity of metals decrease with an increase in temperature, but metals should conduct in all states. And why should the conductivity decrease with an increase in temperature? Because there is an increase in the kinetic energy of those electrons. So in order to make them move in a specific direction, you may have to supply more energy. More energy will have to be supplied so that they move in a specific direction. Furthermore, even those ions are also moving, and therefore as they move, they are blocking the movement of those electrons. So it becomes, the conductivity should decrease with an increase in temperature. Now, but the next question we need to ask ourselves is, now solid substance will either conduct or not conduct. But what about solutions and molten substance, liquids and solutions? Do they conduct? So there are some substances that do not conduct in solid state, but conduct in molten state. We call such electrolytes. You will realize that these are usually, or not actually, they are always ionic substances. Ionic substances will conduct in molten or solution form, but they don't conduct in solid state. But we have other substances that will not conduct, whether it is in solid or molten state. And those are usually not, they are always covalent substances. They consist of molecules. We shall call them non-electrolytes. This particular topic, we are actually concerned with the electrolytes. And let us look at a specific, let's go through a specific experiment to see and illustrate the process that we are going to call electrolysis. Now we will set up apparatus as shown here on that diagram. So I'll have some solid red bromide which I will subject to heat, and I will immerse some rods made from graphite because I want conductors. I will connect that to a switch, a cell, and some bulbs. These rods that are immersed into the electrolyte, I will call them electrodes. Electrodes. So electrodes are rods that are immersed into an electrolyte through which an electric current will either enter or leave. So I need conductors. Now let us look at what happens when I make this particular setup. And I want us, as we observe the next clip, to just write some observation. Just write whatever that is observed.
A circuit is set up using 2 carbon electrodes, an ammeter and a power supply. The white powder is lead bromide. Switch on the power supply and nothing happens. The ammeter reads 0. Solid lead bromide doesn't conduct electricity. It needs to be molten. Lead bromide melts at 370 degrees Celsius. Switch on now and a current flows. In this circuit, the electrode on the right is positive, the one on the left is negative. As electricity passes through the molten lead bromide, chemical reactions start. On the left, at the negative electrode, nothing appears to be happening. But at the positive, bubbles mean a gas is being produced. Placing small tubes around the electrodes traps any gas, making it easier to see their colour. What could the brown gas be? The gas is bromine. Although nothing obvious appears to be happening at the left-hand electrode, pouring the molten lead bromide away reveals a small silvery metallic bead. This is pure lead. So, passing an electric current through molten lead bromide breaks it down into the elements lead and bromine.
This is what you have seen and maybe heard. When the bulb will light. No, let's start from the beginning. When we completed the circuit, the bulb did not light. The bulb only red when the red bromide melted. When the red bromide in solid state was converted to melting, that is when the bulb light. Apart from that, there were some red fumes produced on one of the rod that was connected to the positive terminal. Now the other thing, there was a shiny grey metal deposited on the rod that was connected to the negative terminal. We used to call them grey beads, but we no longer talk of beads. So just remove the beads and just talk of a grey metal deposited on that rod that is connected to the negative terminal. Let us try to explain that. And I will make use of that diagram to explain our observation. Now, when I connect and I complete the circuit, now we were told from physics that electrons will move from negative to the positive. So electrons are going to move in that direction. And through the wire, we have delocalized electrons as we've just talked about. No, they are not free. They are called delocalized electrons. So electrons will move in that direction. Let them start moving anyway. But when they get to this point, they don't find other delocalized electrons in here. They don't find delocalized electrons in here because when you talk about lead bromide, the lead has already lost the 2 electrons in the outermost energy level to the bromine to form the bromide. So we don't have electrons are localized. They belong to lead, they belong to the bromide. So the electrons cannot move out. They cannot move out here. How will they move out? Here we don't have electrons that are old, so they cannot get out there. So they will accumulate on that rod. When they do that, they make this rod to acquire a negative charge. We have excess electrons on that graphite rod. And now that electrons are negatively charged, that rod acquires a negative charge. Now the negatively charged electrode is called we shall call that the cathode. It shall be the electron that is connected to the negative terminal, where the electrons will accumulate. They make that negative and we call them the cathode. We can apply some argument to show that this other side becomes positive. This rod becomes positive and we shall call it the anode. You can remember that if you talk of the pancake, the positive electrode is called the anode, the negative electrode is called the cathode. Now, so we have already gotten some negative rod and a positive rod and give them some name. Then inside here we have ions. We have ions of red bromide that are joined together. They should move. There is attraction. The red ions are attracted towards the negative, but they cannot move. They can't move. Why? Because the red bromide is in solid state. We said in Form 1 that in solid state, ions only vibrate in position. They are doing like this. But vibration is not enough. What we need is the actual movement from where it is so that it gets to that negatively charged electron. So we need it to move. So for ions to move, then you must be in liquid or gaseous state, because that is from the simple kinetic theory. There's movement in liquid or solution or in gases. There's only vibration in solid state, and that is not enough. So that is why we need to heat that. When you heat it, when you heat, you convert the lead bromide from solid state to liquid state so that the ions can actually move. So what will happen after that? The red bromides now, the red ions can move in that direction, being attracted to the negative charge on that rod. They are attracted there, so they move towards that side. And what will happen there? The red ions will gain 2 electrons to become lead. So the red ions gain 2 electrons to become lead. So what has happened is that the lead ions have lost charge. We say they have been discharged. They have lost charge. So it's like, okay, they gain an electron and another, because electrons are negatively charged, you can add negatives to the lead so that it becomes neutral. So it is discharged. So what happens to this electrolyte now? It has excess of the bromide ions. So if there is a negative charge here, how it's now therefore appears like the electrons have been picked from here, they are inside here. But who picked them? The lead ions. The electrons did not jump out. They were picked by the red ions. They are now in that electrolyte. So the bromide ions, on the other hand, are attracted to the positive electron that we have called the anode. What happens to the bromide ions? Note, being a halogen, it ends with 7. The bromide ions has 8 electrons in the outermost energy level. I think it's 2, 8, 18, 8. That is the bromide ions. So it deposits the electrons there. What does it become when it deposits an electron there? So minus an electron. So let me write a minus an electron. It forms a bromine atom. So the electron is deposited right there. So it is coming from 2, 8, 18, 8. That is the bromide ions to 2, 8, 18, 7. That is the bromine molecule. and the electron is right there, it now can move along the wire, and then, of course, you know that this one does not exist, so they'll have to combine in pairs. So we need a molecule, we need 2 of that and 2 bromide ions. Normally we don't write negative, so we carry to the other side. The equation therefore becomes 2 bromide ions to form bromine plus 2 electrons. Let us observe the creep that I have there, so that it can help us to understand what we are talking about maybe better.
Why this happens, imagine you can see the charged particles, the ions, in the compound. There are positive lead ions and negative bromide ions. Once the power supply is switched on, the lead ions are attracted to the negative electrode. The bromide ions are attracted to the positive electrode. Lead ions pick up electrons. They lose their positive charge and form lead atoms. Bromide ions give up electrons. They lose their negative charge and become bromine atoms. These form a gas.
Let's go through the explanation again. So the 2 rods immersed into the alcohol electrodes, we have already said that. When the circuit is complete, the localized electrons move from the negative end of the battery to the electrode that is connected there. They move from negative. They move from negative. Negative is the short line. The short line is negative. The long line is positive. So they move towards that. The real bromide, however, does not contain the localized electrons. It has ions. All the electrons there belong to either lead, they belong to bromide. There is no delocalized electrons as there were in the wire. So when the electrons accumulate there, they make that rod to be negative. So the negatively charged rod will be called the cathode. Let's note that. Now the other rod will be positively charged and will be called the anode. Now the charged rods will attract electrons, unlike charges attract lead ions towards the negative, bromide ions towards the positive. But for that to happen, it must be in liquid state. So the heating was necessary. Heating was necessary so that until it melts, so that the ions can now become mobile. So the red bromide still does have ions, but the ions are not mobile. They are just vibrating. So you need to convert them to ions that actually move. So when they are able to move, the positive lead ions move towards the cathode and are discharged. They lose charge. So how does that happen? By gaining some negatives. You gain some negative. So you want to offset this positive charge, you add electrons. Now you know that this is what you call an oxidation, a reduction reaction. When electrons are gained, you say reduction reaction takes place. So you can talk of reduction taking place at the cathode. The reaction at the cathode is called a reduction reaction. So you have a red card. I don't know whether you have seen that. Maybe, but when you grow up, you'll be able to see some red cards. Now, what happens to the other side? The bromide ions are attracted there. That is the anode. They lose electrons. That is the loss of electrons is called oxidation. So we talk of an ox. So if you have a red card and an ox, then you'll be okay with the electrolysis. So reduction takes place there, and then red fumes of bromine are deposited. So you note very clearly that in this process, you started with red bromide, but you're ending up with lead and bromine. So the red bromide has been broken down. Every time you have a breaking down, we talk of rhesus. Those guys taking biology, you must have heard of hydrolysis. Like you want to convert a non-reducing sugar to a reducing sugar, we say you hydrolyze. My teacher used to tell me to add hydrochloric acid for hydrolysis. Hydrolysis means to break down by means of water. So when you break something using electricity, then we can talk of electrolysis. So electrolysis. So the whole of this process has led to the breakdown of a substance by means of an electric current. We call it electrolysis. So what is electrolysis? It is a decomposition of a substance by passing an electric current. So if that undergoes electrolysis is called an electrolyte, and the substance need to contain mobile ions, because if it doesn't have one, it has to have ions. Two, the ions must be mobiles. If it contains molecules, then there is no attraction towards the various electrodes, because molecules have no charge. So the ions, the substance must contain ions, and the ions are made mobile by either dissolving or melting. Electrolytes can either be weak or strong. If it conducts a lot of electric current, then it's a strong electrolyte. If it doesn't, it conducts weakly, like the weak acids that we talked about in Form 1. We had ethanoic acid, we had citric acid. Those are weak acids. They will be weak electrolytes. So a substance that cannot be decomposed by an electric current, as we said, is a non-electrolyte. It must be molecular. So generally, this is a reaction that takes place at the anode. The anode you have said is the positive electron. So it will attract the negative. To discharge a negative, electrons must be lost. So minus m electrons. So if it has a charge of m negative, minus m electrons to form y. Now, but you don't say minus because we prefer to add. So we take them to the other side. So that is, of course, you've said there is a loss of electron. Oxidation is loss. Oil reduction is gain. Oxidation is loss. Loss of electron is oxidation. So that's an oxidation reaction. And therefore, at this rod, oxidation is taking place. So we talked of an ox and all that. So let us look at some other examples. And this is how we'll be setting up an electrolytic cell. We'll have the electrolyte there, we'll have to heat it. Whatever electrolyte it shall be, a switch and a bulb. So a setup for electrolysis is called a voltmeter. Not a voltmeter, because a voltmeter is an instrument that is used to measure voltage. A voltmeter is a setup for electrolysis. So this is a voltmeter. Now supposing let's look at the question. Show the direction of movement of electrons. Electrons, you've said, move from the negative to the positive. So this is the negative, that is the positive. So electrons will move in that direction. And know that electrons move in wires. If you write something like that, it is wrong. Hey, that would be a very dangerous scenario, because I will not be allowed to stand next to a wire. If I stand next to a wire, I will be electrocuted, because if this is the wire and I'm standing here and the electrons are moving outside the wire, then they will get to me and I will be gone. So electrons should move in the wire. So this is wrong. This is the correct way of showing that. So when that happens, remember the cathode and the anode. The cathode, you said pancake or panic. The one that is connected, the positively charged electrode is the anode. It's connected to the positive. So this is my anode. The one that's connected to the negative is the cathode. Why did it become negative? It has an accumulation of electrons. So that makes this one the cathode. What else? The electron is made from Xn plus Yn. So we need to show the ions Xn plus Ym minus. So the positive will move towards the negative.
Electrolysis of lead bromide only works when the compound is molten. Why doesn't it work when the compound is solid?
Look at other examples of electrolysis. The electrolysis of molten sodium chloride. Now, what are the ions present in sodium chloride? Now, cations. What are cations? Cations are the positively charged ions. The positively charged ions. The cations will cut you. They're just like scissors. Just like scissors. Just like scissors. This one, it will cut you. They are cations. So the cations are positive. So the positive ions here are the sodium ions. Definitely ions are negative. They are the chloride ions. What reaction therefore takes place at the cathode? Where cathode is in positive, the negatively charged. So we're talking of pancake. The negatively charged electrode is called the cathode. So the cathode is negative. It will attract the positive ions. So these are the positive ions. So the sodium in liquid state. What happens here? Red cut, reduction, but reduction is gain. So plus an electron to form a sodium atom, to form a sodium atom. So they have been discharged. So this one may be in liquid state, and therefore what you'll observe there is a shiny gray liquid. Shiny gray liquid, that should be. What about at the anode? We've already agreed that the anode will attract the anions. Anions should be negative, so the chloride ions get there. What will happen to the chloride ions? At the anode, we get an ox, but oxidation is lost. So electrons will have to be subtracted. But we don't subtract, So we get to chlorine plus an electron. Now, but this form of chlorine does not exist. So what do? We multiply by 2. So that we get a chlorine molecule, in which case we need 2 chloride ions, so in liquid state. So we get a green gas. Bubbles of a green gas are produced at the anode. Another example right there, and you can pause and go through it. The anions are negative, so you have the all 2 negative ions. The cations are positive, you have the aluminium ions. The cathode reaction, cathode will attract the cathode is the negative, so it will attract the positive, so Al3 plus 3 electrons to form. To discharge aluminium, it needs to gain 3 negatives. 3 negatives. So we get aluminium like that. In liquid state, of course this was molten, so it's liquid. And so here what do you have? Shiny gray liquid. What do we have here? The anions move there, O2 negative, loses electron to form an oxygen atom. Each of the oxygen will have to lose 2 electrons. So, but this is an oxygen atom that does not exist, so I need to multiply out by 2. Liquid state gas, so colorless bubbles of a colorless gas. Another example, potassium iodide molten again. We're not talking about solutions. What are the cations present? I hope you've stopped of potassium ions. What are the anions present? The iodide ion. What is the reaction at the anode? What moves towards the anode is the anions. So it's the iodide ions that moves there, loses an electron to form an iodine atom. This one does not exist, so it's halogen, so it exists in form of molecules. This one is liquid, but this is gas. It sublimes on heating, so you get purple vapor. Purple vapor. Cathode potassium moves there. What happens to the cathode? The red card, reduction is gained. That's an electron. So this has a low melting point but a very high boiling point. And it was molten. Observation again, shiny gray liquid. Molten magnesium nitrate. The ions present, and ions, the nitride ion, cation, magnesium 2 plus ions, anode reaction, the ions move there, minus 3 electrons to form, then this one does not exist, so multiply out by 2. This is molten. That's nitrogen gas. The cathode reaction is plus 2 electrons to form magnesium. In a solid state, that is basically it as far as the. Now the electrolyte we are talking about here are called binary electrolytes. We have only one anion and one cation, only 2. Only one anion and one cation. So we call them binary electrolyte. They are mostly the electrolysis of molten substances. So in the next, we shall proceed to look at the electrolysis of solutions.